You know, we tend to think of mathematics as this rock-solid place. It's all about pure logic, hard facts, where everything is certain. But what if I told you that just beneath the surface, there's been a philosophical war raging for over a century, a real battle for the very soul of math? So let's dive into this hidden conflict.
I mean, it sounds kind of impossible, right? A crisis in mathematics? But it really happened. The source material talks about a genuine foundational crisis, a moment when the smartest people on the planet realized the ground they were standing on wasn't nearly as solid as they thought. So what on earth could shake a field that's built on absolute certainty? Well, the answer is so simple, it's actually kind of shocking. This whole crisis, this massive philosophical brawl, it all boils down to how you answer one tiny question about one of the most basic building blocks of modern math. What exactly is a set? It's a question that literally splits the mathematical world in two. And to really get what's going on, you have to understand that this isn't a new fight. We're talking about two ancient philosophical rivals, two totally different ways of seeing reality itself that just happen to find a brand new battlefield, right in the middle of set theory. Okay, so on one side, you've got Platonism. For Platonists, sets are real things. They exist out there in some perfect abstract world, and our job as mathematicians is to discover them, kind of like an astronomer discovering a new galaxy. But then you have the other side, nominalism. And for them, that's just total nonsense. Sets aren't real. They're just convenient names we invent, useful labels to help us organize stuff. The universe isn't filled with sets, our languages. Let's dig into the Platonist view first. And this goes way, way back to Plato's whole theory of forms, this idea that there's a world of perfect ideas out there that's even more real than our physical one. The key concept we have to get our heads around here is the universal. A universal is an abstract property, like blueness or courage, that Platonists believe exists all on its own, totally separate from any specific blue thing or courageous person. And their argument is that mathematical sets are exactly that. They're a type of mathematical universal. So here's the absolute crucial point for a Platonist. A set is defined by the idea that ties all its members together, that one shared property they all have. This is what's called the intentional definition. The whole focus is on the intention or the meaning behind why you're grouping these things together. And this analogy really helps it click. For a Platonist, the concept of the 2024 champions is a real, actual thing. It's a universal idea that exists completely separate from the list of players on the team. The property of being a champion is what defines the set, not the people. All right, let's flip the coin and look at the other side, the nominalists. They bring everything crashing right back down to earth. Their whole deal is that we should only care about what we can actually see and point to. The golden rule for nominalism is something called the principle of extensionality, and it is super direct. A set is nothing more than the list of things in it. That's it. You define it by literally extending your finger and listing out every single element. If you change even one thing on that list, poof, you've got a completely different set. So let's go back to our sports team. For a nominalist, the team is the list of players. Full stop. That name, the 2024 champions, isn't some real floating abstract idea. Nope, it's just a handy label, a convenient way to talk about that specific group of people, what the source calls a façon de parler, which is really just a fancy way of saying a way of speaking. The great philosopher and mathematician Bertrand Russell was a huge player on this team. He argued that the symbols we use for sets, or classes as he called them, they're not names for real things. They are just, in his words, conventional signs. They're tools we use for logic. They are useful fictions, not cosmic truths. So for a little while, these two camps, Platonists and nominalists, they could kind of just argue past each other. But then Bertrand Russell himself dropped a logical bombshell that threatened to just completely shatter the foundations of mathematics. And this is where things get really, really weird. It's a mind-bending question, so take a second to wrap your head around it. Imagine you have a special set, let's call it R, and the only rule for getting into this set is this. It contains every set that is not a member of itself. Now, here's the simple, devastating question. Does R contain itself? Okay, let's just walk through this logic trap. First, let's say the answer is yes. R is a member of itself. Well, if that's true, it violates its own rule, which says it can only have sets that don't contain themselves. So, boom, a contradiction. Okay, so what if the answer is no? What if R is not a member of itself? Well, then it perfectly fits the rule for membership, which means it has to be in the set. Boom, contradiction again. It's a perfect trap, there's no way out. Now, this wasn't just some fun little brain teaser. This was a full-blown crisis. And this paradox, it hit one side way harder than the other. The source material says this made sense primarily as a paradox for the nominalist, whose whole system was built on sets being these simple, straightforward collections. This paradox showed they could be anything but. So, did Russell's paradox just blow up the nominalist argument and hand the victory to the Platonists? Did it finally settle this huge debate once and for all? Well, the answer is a big fat no. See, instead of ending the war, the paradox just gave both sides new weapons. It didn't solve anything. It just made the core disagreement, the real heart of the problem, sharper and more urgent than ever before. It forced everybody to ask, what in the world are these mathematical objects we're even dealing with? And that's pretty much where things still are today. As the source material puts it, just very bluntly, the disputes between these two sides cannot lead to a constructive solution. They're talking past each other because they have two fundamentally different views of reality. Logic alone just can't build a bridge between them. And this is why this whole thing is still so fascinating. The debate never stopped because it was never really just about math. It's a proxy war for one of the oldest, deepest questions in all of philosophy. Is the universe built on a structure that we find, or is it a structure that we create with our own minds? So I'll leave you with that question at the very heart of this entire battle. When we do math, are we explorers mapping out this hidden, abstract continent that's always been there, just waiting for us? Or are we more like brilliant architects, inventing this incredible, powerful language to describe a world that has no mathematical structure of its own? The battle, you can be sure, continues.